Hello and welcome back. In this lesson, I want to talk about some specific terminology that you're going to need to know to be an effective solutions architect and to do well on the CSA exam. Also, these are extremely important concepts to know as a solutions architect and especially when building applications inside of AWS. So at any given time, you can access this terminology and their definitions by clicking on and going to the appendix and then clicking on the terminology tab. So these are the terms that we're going to cover, and it's very important that you understand these concepts now because I'm going to be referencing them a lot throughout this course. And you're going to see these terms a lot in a lot of the quiz and exam questions, both here in Linux Academy and most likely also on the CSA exam itself. So let's start with high availability. So high availability refers to systems that are durable and likely to operate continuously without failure for a long period of time. For a solutions architect, this means making sure your application, if it's hosted in AWS, is always available when a user or customer tries to access it, right? So that's the basis, right? You hear the word high availability. What does availability mean? Availability means it's accessible. When you go to access it, you want it to be accessible. And a lot of times, high availability can be measured by a metric. You may see things like 99.99% availability or something higher. And it just means that. It just means that when I go to access my file or I go to access my server, is it going to be accessible? And many of the services in AWS are already highly available because of the way that AWS infrastructure is set up with redundancies and backups. Going with high availability is fault tolerance. So fault tolerance is the property that enables a system to continue operating properly in the event of the failure of one or more of its components. So a fault tolerant application in AWS would be where one of its web servers, as an example, can fail and still serve traffic to visitors and even repair itself through something like auto scaling. And we'll get to that as we get into the networking sections of this course. So high availability and fault tolerance usually go hand in hand, and you will hear the term over and over again, a highly available and fault tolerant application. So these two terms go hand in hand, meaning that you always want, as a solutions architect, to design architecture for high availability and fault tolerance. So you always want your application to be available when somebody requests it to be available, and you also want your application to still work if parts of it start to break and then even be able to repair itself. Next is scalability. So scalability is the ability of a system to easily, and I use the term easily here, increase in size and capacity in a cost-effective way. And again, it's usually to increase in size based on usage demand. So with scalability, you hear this a lot while comparing traditional on-premise data centers to using cloud providers like AWS. It is much easier to scale in the cloud than it is on an on-premise data center. So you take this for an example. Say that on your on-premise data center, you're noticing that you are having increased usage on your servers. In order to increase your server capacity, you will need to order new servers, meaning that you will have to price them, order them, wait for them to come into the mail, physically install them in a rack, boot them up, load software onto them, connect all the network cables. There's a lot that goes into that, and that may be a several day or several week process. With AWS in the cloud, you can generally provision new servers within seconds. So in the cloud, scalability is much easier than it is on an on-premise data center. With that goes the concept of elasticity, and this is the ability of a system to increase and decrease in size, usually based on usage demand. So in architecting applications, this usually refers to the ability of an application to increase and decrease server capacity on demand. So where it's easy to scale up when traffic demand may be high, what happens if only a few hours later or a few days later, traffic demands decrease? Well, if you had an on-premise data center and you had ordered and paid for all of these servers on your own, you now have a bunch of servers that are not being used. In the cloud and AWS, elasticity just refers to the fact that as demand decreases, you can just scale down and get rid of those servers, and then you're no longer paying for them. So scalability and elasticity are, again, two great benefits of using the cloud. Next is cost efficient, and this is just choosing the correct options to make a system as inexpensive as possible. So I'm going to talk about this as we go through various services throughout this course, and what we'll just generally touch on are different buying options or different ways of utilizing cloud and AWS resources in a less expensive way than either on-premise data centers and the costs associated with those, or even within AWS, how to best architect something to make it more inexpensive than choosing other options within AWS. Next is secure, and this is just following proper security guidelines and practices to secure a system. So we're always going to want, when we set up our applications and our architecture in AWS, to always have security in the back of our mind and make sure that we are taking the proper steps to make sure that our architecture is secure and the applications running inside the architecture have proper security set up on them. Last is AWS best practices. And AWS best practices are a set of guidelines outlined by AWS, which is generally noted in their documentation and white pages, that should be followed when provisioning and using their services. So AWS has done us all a great service by saying, hey, for each one of these services, here are some key points that you need to know, which we consider to be the best way to use these particular services or utilize security in the best way on these services. So again, it is extremely important that you have a good understanding of these definitions and the concepts that they represent, because they are going to be repeated numerous times throughout this course, and they're also the foundation of what being a solutions architect is, and making sure that you are using all of these concepts and principles in your daily workflow as you design architecture for various types of applications in the cloud. So with that, we will conclude this lesson. Thank you for watching. You may now move on.